Hello, my name's Noah Comer. This is our project for quadratic applications. Our title is Ben and Jake Get PS5. Over there behind the camera is
Riley.
And so I guess we'll go ahead and start off. Alright, so here's our word problem. Jake gets a PlayStation 5 at Walmart during the Black Friday sale. He wants to leave with it, but there's a mob between him and the exit. He decides to climb on top of a 6-foot tall rafter and stretch to 5 feet tall to toss it towards Jake, who's by the exit. How long will it take to reach if he throws it at 20 feet per second? Here's how we got our axis of symmetry. We took our equation, negative 16x squared plus 20x plus 11, and then used the formula, negative b over 2a, to get negative 20, because negative 20, and negative 32, because 2 times negative 16. Negative 20 over negative 32 ends up equaling 0.625. So our axis of symmetry is x equals 0.625. So next, we take our axis of symmetry and plug it into our equation, 16 times 0.625 plus 20 times 0.625 plus 11, and we get 17.25. This is going to be our maximum, and together they are our vertex. So we have 0.625 comma 17.25 for vertex. So next, we get our y-intercept. We do this by looking at our standard form equation, ax squared plus bx plus c, and we take our c. In our case, our c is 11, so we get 0, 11.
Hi, I'm Riley, and I'll tell you how to solve each equation. First, we're going to start with the square root method. For the square root method, you would take your equation above and try and use this and this to make a perfect square. However, it's not possible because the 11 cannot be squared away. Next is the factoring method. The factoring method is not possible because we have no factors of negative 176, which happens when you multiply these two together. We cannot factor it, therefore the factoring method cannot work. Next is completing the square. To start off with completing the square, we take our equation and subtract our c variable for each side. This is, in our case, 11. Then we'll divide by our a variable, which is negative 16, to get this equation right here. Then we're going to take our b variable, divide it by 2, and square it to get this right here. After that, we're going to find the square root of both sides, and you'll come out with x equals 1.66 and x equals negative 0.0041. This, however, is not applicable because it is a negative number and we cannot have a negative time. Next, for the quadratic formula, you're going to take your equation and put it in through here. This is going to be your negative b variable, which is 20, so you're going negative 20 plus minus the square root of b squared plus 4ac, so times negative 16 and 11 together, then times that by negative 4, and you'll get this number right here, over 2a. 2a is right here. You're going to go down, add these two together to get 1104, then simplify down to get this and end up with the same as what's down here. Again, this is not applicable because a time frame can't be negative, and you end up with x equals 1.66. This is our graph. The y-intercept represents the place at which Jake is tossing the PS5 from. This is shown by the drawing here, and this height is 11 feet. Then we get to our maximum value, aka our vertex, which is 0.625 to 17.25. This is the highest that the PS5 travels before falling back down to the ground. And our x-intercept represents the time it takes for the PS5 to reach where Finn, our friend, is diving for it. This time is 1.663 seconds. Thank you for watching our video. To summarize, the axis of symmetry is 0.625, the vertex is 0.625 to 17.25, the maximum value is 17.25, the y-intercept is 0 and 11, and the x-intercept is 1.6630.